Well, welcome to my first test video, and to test my video and my abilities to do this, I'm going to try and quickly explain a little bit of octal and hexadecimal. As said on the video, on the channel, the whole point of me doing this is for me to learn what I'm doing, revise, and hopefully this will help you do the same. So we'll quickly move on to a bit of a hexadecimal. Binary. So if you're doing computer science or you're interested in computers, you'll understand that the computers use binary. Why does it use binary? Well, it's easy to turn electric on or turn electric off. So it only has two states. It has on or off. That's all it has. Now, if I want to represent a number in decimal, which is to the power of 10, and I'll explain that bit. If I want to represent 111 in decimal, I have 1 1, 1 10, and 1 100. Now, some simple maths. 1 times 10 equals 10 times 10 equals 100. So this is how you can see by the power of 10. So binary works very similar. Put my little one back. It's got 1. It's only got 2 states. So times 2 is 2. Times 2 is 4. Now each one of these is 1 bit. Let's call it 1 bit of information. I'm sure you'll talk to computer scientists and they'll tell you that's not quite right, etc. But this should hopefully help you to learn. If my way doesn't teach you how to learn, doesn't teach you anything, that's fine. Everybody teaches and learns differently. So we'll write some binary down. 1, 2, 4, 8, 16, 32, 64, and 128. You'll notice some of these. I mean, you've got 32 here. You've got a 32 gig hard drive, 64 gig, 128 gig. Computers like these numbers. Okay. So if I want to represent 128, I put 1 bit there, but I need to fill all these in. It's a little bit like having in decimal and putting a 1 there. What does it represent? It represents nothing. It needs the zeros behind it. Same in binary. To represent 128, it needs all these behind it. Right. So we're getting somewhere. We're learning a bit of binary, learning what it all means. Computers turn them on and off. Right. Now we're going to skip right past the binary bits because we'll cover it in another video sometime and we'll go way back. What we're going to do today is octal and hexadecimal. I'm not going to cover them in depth because if you know it, you know it. If you don't, it could blow your mind at this point. But we will cover it in more depth at some point. Octal 8, hexadecimal 16 to the power of, same as 1 times 2 equals 2 times 2 equals 4. We get the same here, we get 8. Ooh. We get 8. No, we don't. That was wrong. We get 1 times 8 equals 8 times 8 equals, here we go, 8 times 8 is 8, 16, 32, 64. Straight away we go to 64. So you could represent those numbers, which would be 64, 8 and 1, 4, 12, 13, 73. So those three bits of binary, sorry, those digits could represent in hexadecimal 73. So let's look. Let's quickly look at octal. Sorry, 111. Right, we want to represent this in binary. We need, each one of these needs to represent up to 8 digits, which is 0, 1, 2, 3, 4, 5, 6, 7. That is 8 different digits. All computer science will start at 0. All your hash maps, all your arrays, all start at 0. Indexing. Again, something for another day. Same as your decimals did. 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10 of them. There you go. Here's your decimal, here's your octals. We need to represent all these. One lovely little way to represent them in binary is with the first 3 digits, which is 0, 0, 0 equals 0, 1, 0, 0 equals 1. So quickly go through them. 2, 3, 4, 5, 6, 7. So 2, 3, 4, 5, 6, 7. As you'll see, these 3, if I put them under the 1, 2 and 4, 1, 1, 1 is 4, add 2, add 1, so 4, add 2, add 1 equals 7. So you can go all the way from 0 all the way up to 7, and this is your octals. Right, I'll try and go back here and clear my screen a little bit so I can have some real estate to do some drawing on. Please do give me some feedback on all this, because you might make some sense to me, and I might be going completely off one here. So where are we going? Let me get my pen back. There we go. Right. So to represent 111 in octal, now you'll see a 0 at the beginning of octal, and what you'll see is a 0x at the beginning of hexadecimal. The easiest way that it helped me through my exams is O for octal, X for hexadecimal. It's the only way I can remember it. So 111 in octal is 3 digits, 1, 2, 3, and it's going to be 1, which is 0, 1, 0, 0, 1, 0, 0, 1, and 0, 0, 1. Something's just occurred to me. What does that add up to? 1, 2, 4, 6, no, sorry, 8, 16, 32, 64. What does that add to? 64, 8, and 1, 4, 12, 13. Strange that, isn't it? If you notice,